Good morning, everyone. Welcome to our group presentation. My name is Lakshay Agarwal, and we have Rajesh Chivella with us. Today, we will be discussing our paper on using model driven engineering to automate software language translation.
So, in today's session, we'll delve into some of the challenges of program translation and some of the methodologies employed and some empirical studies conducted and the practical application and also some further research direction, and also we included some insights of the paper as well.
Now, basically, the overview of the this paper is nowadays the organizations wants to reduce their maintenance cost, which can and one of the methods or major maintenance cost is the language using. So they want to shift from Java to Python or maybe another code which may reduce the maintenance, but the main thing is we do not need to change the accuracy, and efficiency will be our main challenges in this paper.
So, in this paper, we utilize reverse engineering to convert source code into UML based specifications, and then we used forward engineering to translate these models into some required target language. So, our methodology demonstrate the superior performance compared to some traditional approaches, as shown in the upcoming comprehensive evaluation matrix. So, the techniques used for the topics are some reverse engineering, and through the comprehensive evaluation also they demonstrate their superiority of their methodologies compared to with the traditional approaches as well.
So the objective of this paper is how we are going to enhance the original programming language source code, and how we are going to translate it, and how we will overcome or solve the traditional methods used in this, and how these traditional methods are way different from the approach used by MDE.
And also additionally the paper emphasized the importance of addressing semantic preservations and some specifications from the code. So these are which are crucial for maintaining the functionalities and the behavior of the code as well. So we are using some leveraging MDE techniques which ensures the precise translations and the behavior of the software code. So this approach significantly reduces the manual intervention and some potential errors we may get, which will result in more efficient translation workflow.
The main challenges faced while translating the program and the are accuracy and efficiency. Semantic presentations. Accuracy is basically how accurately we are going to translate one program to another program. For example, if we are translating from Java to Python, so we have to maintain the accuracy, because if we are not maintaining the accuracy, then some of the requirements of the clients may be missed, and if the efficiency is compromised, then maybe the bugs, errors, or anything can be needed to be faced in the future. So we cannot compromise with these two challenges majorly.
And also, while the upcoming slides, we also go through the limitations of traditional methods. The paper goes on into more detail about specific challenges faced by these approaches, such as some potential errors, inconsistencies, and some scalabilities as well. So, by using reverse and forward engineering methodologies, we aim to streamline the translation process and also while addressing these core challenges, which will ensure that the translation software is originality and functionality.
So for as we have talked, why we are using MD approach other than traditional approach. So basically the approach is using reverse engineering technique and forward engineering technique. In reverse engineering technique, basically We abstract the semantic models to get the UML diagram from the source code, which gives the overview or the which analyze the behavior and the structure of how the source code is reacting to the specifications.
So the paper highlights the importance of leveraging the model-driven engineering technique, which ensures the efficient translations. So how the code and the software is working on. Once the models are established, the forward engineering is used to translate them in the required language that we need. So this step ensures the accurate translation of software functionality and the consistency with the original specifications as well.
Basically, using this approach, why it is beneficial. So the main benefit is semantic preservation.
And some precise specifications.
By prioritizing this, we ensure that the behavior of the original software is maintained throughout the translation process.
So it also the potential cost saving as well, reducing the retesting efforts that can result in accurately translating the code, and also it involves some of the advantages like extracting precise specifications from the source code, which will minimize the loss of functionality. So this approach reduces the manual intervention, which will result in efficient translation, and also it is a faster time to market for software applications.
Now, why we can detailedly go what this methodology or proposed approach can do. First, the reverse engineering. Basically, reverse engineering means extracting data from the core source code or anything. These data can be extracted using the semantic models, where we have the behavior or where we extract the behavior of the class, relationship between the classes, attributes, and etc.
So additionally, the paper provides the insights into specific techniques and also tools used for the data collection and analysis, which are included with statistical analysis as well. And also in this methodologies used, we are included some UML diagrams, which serves as the foundation for a subsequently translation process. So these semantic models which are used are essential for ensuring the translation process for a required code.
Uh, Once the semantic models are established, forward engineering methodologies translates them into the required target language. This ensures that the translated software preserves the intended behavior and functionality of the original code.
So this process also involves converting semantic models into executable code in the required language. So maintaining the semantic correctness and the consistency with the original specifications in the forward engineering.
To evaluate this approach, they have gone through empirical approach, where the real world the author conduct the empirical studies through the software applications, and this gives the translation accuracy, semantic prevention, efficiency, and etc.
So the studies also provided comprehensive data on metrics such as translation accuracy, semantic proficiency, and efficiency. So this results demonstrate and the superiority of our methodology when we compare to traditional approaches.
So the process of methodology used for this programming translation is like we have a source code in a file called L1. We use the ANTLR software which pass through the source code and give us this syntax trees, which are called ASTs. Then CSTL script will abstract those ANTLR syntax trees and give us the semantic modeled UML diagram, which knows how the behavior of the class is going on and etc.
So as you can see from the diagram, so the resulting UML specification includes some class specifications and some use cases. So which are then you can see here ANTLR and some abstraction and the agile code generation for L2. So these are used in forward engineering and to map the abstracted specification into the targeted languages, and also by establishing the embedding techniques.
So the model, why we used the model, is basically because semantic model is playing the major role, which is giving us the UML diagram, which helps in getting the purpose of accurate translation and giving the accurate analysis about how this behavior and abstraction is going on.
As we know, maintaining the core idea during the translation is crucial for preserving the functionality and behavior of the code. This also requires some careful attention and detailed to language semantics. So, mostly this paper focuses on reverse engineering the source code into the detailed semantic models. So, by apprehending the essential semantics from the pseudocode, it reduces the retesting cost and gives the correct translations as well. We also mentioned some challenges here, and we also do how to overcome those challenges as well.
So basically, the data collection and analysis is about how what data is collected and how we are going to analysis on those gathered information. So we will test on how it is accurately going, and matching with the studies we have done, and how statistical analysis and quantitative assessment is collected for our conclusions.
So in the validation, this validation process ensures that our proposed approach meets the challenges of the program translations and how it is performing efficiently in terms of accuracy and semantic preservation and the efficiency. So by the performance in terms of accuracy, the author validate the correctness of the code that is generating after the user is needed.
So we were talking about traditional approach from the beginning. So the traditional approach is mainly the manual translation, direct language to language translation, and machine learning approaches. Manual translation is like he needs to have expertise on the source code of the original script and the transforming language. Then, while transforming the maintenance cost for labor intensive and it can have he can take a lot of time to convert this, which can lead to potential mistakes, errors, and compatibility issues of the software.
Our approach also addresses these limitations by providing some semantic and automated process which will ensure the accurate and efficient translations and maintaining the integrity of the original software. As we have seen here, we have mentioned about machine learning approaches. So this will automatically generate by the approach utilizes the large data sets from the source code algorithms. So it suffers from limitations such as data scarcity, semantic ambiguities, and generates some transition rules.
So we will once again tell what are the limitations discussed in the previous slides. The main limitations are time consuming during manual processes, which can lead to potential errors and inconsistencies in the codes. And then limited automation and scalability can lead to difficulty in handling semantic ambiguities and domain specific nonsense.
So our approach overcomes these limitations by leveraging some MDE techniques as we mentioned earlier before. So which will provide more automated, scalable, and accurate solutions for the software language translations.
So basically, our main evaluation metrics were for translation accuracy, semantic prevention, and efficiency, because these are the three main evaluation metrics we have to go through without changing the requirements of the client, if and how accurately the previous developer in those original scripted source code is given.
So, as he discussed the evaluation metrics of three, these metrics provide a comprehensive assessment of our methodologies, effectiveness, and which will ensure that the translated software meets the desired criteria and will get performed as expected.
So as you can see here, we have two accuracy and efficiency, where we are talking from the beginning. So here you can see where Java does not have best accuracy while converting it to the Go. So we prefer on going Java to Swift or C hash, which has higher percentage, but you can see Python also has the higher accuracy percentage from Java to Python.
So in this figure, we are comparing through computable accuracy and runtime efficiency. So these are the different kinds of languages that we compared with. We have evaluation cases here. So we can see how the each program is working through this analysis.
So the tools used for these metrics are um, QVT, ANTLR, ATL, etc. But the author used ANTLR to get the source code parser and give the UML object. But according to the picture, we can use ATL, which gives the abstract and accurate UML diagrams.
So our comparative analysis. So this is a comparative analysis slide. So our comparative analysis evaluates the accuracy and the translation of the produced by our approach versus the traditional methods. So we also examine the semantic preservation, efficiency, scalability, and adaptability so to different types of softwares like languages, highlighting and flexibility of our methods.
So here you can see there are the approaches used for the comparative analysis with their advantages and disadvantages. As we can see, the MDRE has an advantage of precise producing modules, whereas the advantage of ML is mapping construction, automated mapping construction, which is a lot beneficial than precise produce models. But his main disadvantages is implicit mappings, which can lead to so many misleading behaviors and which can miss some requirements of the client.
So, as discussed earlier, our approach can be applied to language migration projects, which will enable efficient migration of leveraging techniques. And as you can see in the figure, we are checking for language migration and cross-platform development. So language migration, which will deal with the languages where the software application need to update the unsupported programming. By leveraging the reverse and forward engineering, the organizations can be efficiently migrate their legacy system to more sustainable platforms.
In cross platform development, our approach allows to the translation of software applications with multiple target languages, which can enhance in market reach and operational systems. The future research directions is basically how we can use these paper for our future research is while translating the MDE, translating the programming languages using AI or ML instead of MDE for improvement of accuracy and efficiency, or else we can use for automation and how optimistically we can reduce our source code in the uh, source code using the code generation and validation with the specific semantic analysis and the understandings.
So, and also other areas including enhancing semantic analysis and understanding, and also automating the optimization, the translation workflow. As he discussed some techniques as AI, ML, NLP, which will improve the accuracy and scalability as well. So the industry academia, which will and establish the connection between the industry and the to facilitate to more marketing findings into practical applications which will enable the methodologies into real world softwares.
So the legacy system modernization is can benefit significantly from our approach, providing a semantic method for updating, modernizing software systems.
So, by translating the code bases into modern programming languages, organizations can extend into some lifespan of their software assets, which will ensure that it is compatibility with current technologies.
So software so how we can use this in our course is like while translating one program to another program, maybe they haven't used some of the patterns, or they haven't used any pattern, it can happen. So we can use these five major five patterns like builder pattern, adapter pattern, visitor pattern, strategy pattern, observer pattern, and interpreter pattern, where it can ease in the understanding of the source code. In future when they are translating, they can easily understand, and you can increase the accuracy of the source code.
And also, these patterns ensures the robust and adaptable translation processes, which will help in interpreting and parse source code specifications. So, constructing translation objects and integrating them with the existing code, which are used by these patterns. And there are some other patterns as well, which are there are many patterns, but we haven't included all this. So, some of the patterns we are included are used by our course.
To ensure accuracy and reliability, we employ several testing methodologies, including unit testing, integration testing, regression testing, validation testing, formal and informal testings.
So these tests verify the correctness and the functionalities of the individual components, which ensures that seamless integration, and also they will detect any regressions and validate the translation software against the predefined criteria.
So, significance of our software engineering is how our research contributes to the advancement of software engineering by providing an efficient approach addressing the key challenges for the software development and their modernizations.
By improving the translation accuracy and efficiency, our methodology supports the development of more maintenance and scalable software systems.
In conclusion, our approach using MDE techniques, specifically reverse engineering to ML and forward engineering, achieves accurate, efficient, and semantically preserved translations.
So, our empirical studies or comparative analysis validate the superiority of our method over the traditional approaches that we have discussed before, highlighting its practical applications in cross platform development and the legacy. So, the future directions for the research in this paper may include some advanced translation techniques by using AI and the semantic analysis for the automation and many insights which will are for further innovations.
We would like to acknowledge and thank the various sources and references that have contributed to our research and the development of our methodology.
So, these references have been instrumental in shaping our understanding and our approach to software language translations and some techniques.
Thank you for your attention. We now open to your question. We you may have regarding our presentation and research.
So, we look forward to discuss any queries or thoughts you have for further elaboration. You can comment down below. So, we'll let you know if there is any query left.